videotape will demonstrate how to machine or chase tapered pipe threads. A tapered pipe thread permits a tighter connection that would be possible with a straight thread. As with other thread forms, tapered pipe threads have a standardized system, the American Standard Taper Pipe Thread Series. For a rougher thread finish, the tapered pipe thread can be chased with a die. For a finer thread finish, the thread should be machined on the lathe. After you have viewed this videotape, you should be able to identify the safety precautions to be observed when working in the machine shop and cutting threads on the lathe, use the correct nomenclature for tapered pipe threads, and describe the setup and procedure for machining an American Standard taper pipe thread on the lathe. Always wear safety glasses when working in the machine shop. Keep sleeves rolled above the elbows, and remove rings, watches, and other jewelry. The proper nomenclature of tapered pipe thread includes the thread angle, which is the included angle between the sides of adjacent threads. On tapered pipe threads, the thread angle is 60 degrees, the same as that of unified V threads. Thread pitch is the distance from a given point on a thread to the same point on the next thread. The pitch is the reciprocal of the number of threads per inch. For the 3/4 14 thread to be machined in this demonstration, the pitch in inches is 1 divided by 14, or 71 thousandths. The crest is the top surface that joins the two sides of a thread. The root is the surface that connects the bottoms of two adjacent threads. The crest and root of the tapered pipe thread are slightly flat or truncated. Thread depth is the distance from crest to root of a thread measured at a right angle to the thread axis. For tapered pipe threads, the thread depth is 0.8 times the pitch. The truncation of the root is produced by grinding a small flat on the tool nose, square to the length of the tool, that is a width equal to 0.033 times the pitch. The taper of the American Standard pipe thread is 3/4 of an inch of taper per foot. Nominal pipe size is a designation given to the pipe that has no reference to the exact dimension of the pipe. The outside dimension of the pipe is found by either measuring the pipe or by referring to the table in the machinery's handbook. The pitch diameter of the tapered thread, like that of a straight thread, is the diameter between the two pitch lines. The pitch line is that point on a thread where the cross-section of the thread and the width of the groove are equal. The pitch diameter of a tapered thread is calculated at the small end of the thread with this formula. Pitch diameter at the beginning of the thread is equal to the major diameter at that point minus the quantity 0.050 times the major diameter plus 1.1 times the pitch of the thread. The length of a taper thread can be found in the machinery's handbook. The large end of the taper thread will have approximately 2 slightly imperfect threads, which will not accept a mating part. The length of the effective thread plus the length of the imperfect thread gives the length of taper that must be cut on the end of the pipe. To machine a tapered thread on the end of a pipe, mount the pipe in a lathe chuck. The squared end of the pipe may be supported by a pipe center or a live center. Set the taper attachment to cut a taper of 3/4 inch per foot, and machine a taper on the end of the pipe equal to the effective thread length plus the length of the imperfect thread. For a 3/4 inch diameter pipe with 14 threads per inch, the length of taper to be machined at the end of the pipe would be 793 thousandths. The major diameter at the small end of the pipe should be 1 inch 25 thousandths when this taper has been cut to length. A threading tool ground to a thread angle of 60 degrees and having 0 degrees back rake is used to cut the thread. The tool nose is ground slightly flat to a width of .033 times the pitch. For a 3/4 14 tapered thread, the pitch is 71 thousandths. So, .033 times 71 thousandths gives a tool nose width of 2 thousandths. Swivel the compound to 29 degrees to the operator's right to machine these threads. The same as for machining 60-degree V threads. Place the center gauge against the outside diameter of the pipe on a straight portion of the pipe and align the threading tool in the notch of the center gauge. This aligns the tool square to the axis of the work with a tool at center height. The thread will be cut to the proper depth with the taper attachment engaged. Make certain that the backlash is taken out of the taper attachment. To do this, run the tool off the end of the work to remove the backlash and then bring it back toward the headstock. Reset the spindle to a low RPM for threading and set the quick change gearbox to cut 14 threads per inch. Engage the clutch. Using the crossfeed and carriage hand wheels, bring the tool to the end of the work and pick up a cut. Then, using the carriage, move the tool off the end of the work. Set the compound dial to 0 and the crossfeed dial to 0. Take a 5/1000th depth of cut on the compound and engage the half nut. Since we are machining an even number of threads, the half nut can be engaged at any line on the thread chasing dial. Take a scratch cut on the tapered portion of the pipe. Shut off the machine and check the number of threads per inch. If the quick change gearbox is set properly, then return the tool to the end of the work. Return the crossfeed to 0, lubricate, and continue taking cuts with the compound until the thread has been machined almost to size. Clean the thread. Now check the threads with a taper thread gauge or try the mating parts when a perfect thread appears to be forming on the small end of the taper. If the mating part screws onto the work approximately 4 threads, or the length indicated for hand-tight engagement in the machinery's handbook chart, the thread is to size. For a 3/4 14 pipe thread, the length of hand-tight engagement is 339 thousandths. If the mating part will not screw onto the thread this length, lubricate and continue machining until it will do so. The mating part screws onto the tapered thread the specified length, so this part is finished. To review this videotape, you should now be able to identify correct shop safety practices, use correct nomenclature for tapered pipe threads, and describe the procedures for machining an American Standard pipe thread on the lathe. Machined pipe threads are used on instruments or equipment requiring a precision fit on a tapered thread. The tight seal that results cannot be achieved with die-cut threads. The machinist should know how to produce this useful thread form on the engine lathe.